Cool. Thank you so much, everyone, for joining us today. I'm Nitin Agarwal, and I have Murari, one of my very good friend and one of the AI experts, directly talking from India. In this session today, for the next 1 hour, we will be discussing about various options on one of the very common topic we are getting these days. That's about how should I tune my foundation models. We will be digging deep on the meaning of tuning, that how we can mystify or demystify this particular word primarily. So many definitions, we're talking about so many methodologies. Tuning itself, it's a very, very complex word, that what do you mean by tuning? And in this particular context, we will be talking about how you can tune your foundational model. Foundational model, by the meaning, it's like a large language model for now we are focusing on. And in the last, we are going to show you a demo that how quickly and how fastly you can actually tune your foundational models on Vertex AI Studio. Please feel free to share your questions, your comments. We have collected some of the questions from our viewers, but if you want to ask any live question, please feel free to ask, and we'll try to take as many of them as we can. So I'm Nitin. I lead AI services team, focus on healthcare, life sciences, and generative AI, based out in Sunnyvale, California. And Murari, my friend, he is one of the experts in data analytics and AI, and logging in from India. These are going to be our four-pronged agenda for today, like introduction for tuning, what kind of a things that we can actually do, how the concept of tuning actually come into the picture, some case studies or some use cases that will be very much focused on tuning. In the second part, we will be discussing about various methods, that how you can do the tuning, some methodologies like RLHF, PEFT, LoRa, self-tuning, DSS, multiple things. Definitely, I will try to go little bit in depth, but not very much in depth. We got some equations, mathematical equations, as a part of the slide deck. Don't get scared of. We are just going to glance over it. If you want us to go into the deep into this particular concept, we can come up with one more session. Please feel free to share your feedback. Third point, we will be discussing about how you can implement that thing on Vertex. And finally, some of the key considerations, that, okay, what kind of a key consideration you will be focusing on while going for a tuning, what kind of a basic questions you should be asking from yourself and as well as from your business stakeholders, and one sample use case. And then we are going to show you a quick demo, that how you can actually implement it on Google Cloud, how easy it will be. And then we are going to compare the results from tuned model versus our untuned model or base foundational model, and the difference in their performance or their behavior primarily. Cool. So let's quickly start with introduction to tuning. When this tuning concept came into the picture, or when the whole large language model came into the picture, the first question that came up is a huge model. How can I customize this particular model to my needs? And that raised a lot of requirements on the concept of tuning itself. These are the four blocks that you can see on the screen, where we can say that, okay, how you can customize a large language model. On the most left side, you can see a pre-trained model. That's a frozen model. You can call it as an API based thing. Prompting can be like a zero shot, single shot, few shot, multiple processes like chain of thoughts and everything. But the point is, you are not making any impact on the model. You are not tuning, training anything. Definitely, you can add a temperature, K values, and something like that, but it's not you are tuning anything, but you're actually providing your feedback to the model and generating some results out of it. So you are carefully authoring those prompts, so that you are telling the model that what kind of a response that you're expecting. You need a very, very limited example, 1 to 10, sometimes even 0. You can do it for all the foundational models like text bison, chat bison, Gemini models. Irrespective of the models, you can implement this particular prompt design, or you can call it as a prompt engineering. The second concept we're talking about, it's a supervised tuning. Supervised tuning, PEFT, parameterized efficient fine tuning, PET, PT, you can talk about LoRa, multiple options. But the idea behind this one is that you're actually teaching your model about the specific data set that you want to use and the results that you want to generate based on that kind of a data set. So eventually, you are changing the behavior of this kind of a model. To give an example, and we will be sharing that example as a part of our quick demo, I'm saying is that I want to generate the opposites of a word, like antonyms of a word. In my current large language model, I can ask a question, hey, what is the opposite for this particular word? Or the second thing is, I can actually add some certain words and their opposites and tune a model, so that I'm just providing a word and I'm getting an opposite word as an output. It's a very simple use case. This use case can actually go complex if you go into like processing healthcare documents, physician notes, you're talking about processing your analyst reports, and so on and so forth. So the complexity will just keep going on and on and on. The second thing we're talking about is that it does not require lots of samples, lots of examples. You can only run for, like, for an example, few hundreds or even sometimes few tens of the examples, so that you will be able to tune that particular model. Some of the concepts that you can actually use as a part of text bison model, chat bison, code chat, these are the options already available on Vertex AI, but definitely it will be expanded and extended to all various kind of a models or multi-models approach that's coming up. The third kind of a segment we're talking about customization and tuning, it's RLHF, reinforcement learning human feedback. The concept remains very much similar as that of reinforcement learning, where we used to have a concept of reward function. We will say that, okay, hey, I'm actually getting a response, but then I'm providing thumbs up, thumbs down, some reward, like either penalty for that particular response, and the model is learning from that particular thing. Just like the reinforcement learning learns, it's a very similar concept. So you require some good amount of data, at least like a few thousands of data in a range of 10, 20 thousands of paired examples, so that you will be able, your model will be able to learn from it and will start making some sense out of it. Some of the options available with RLHF, it's like T5, small, large, and extra large models, text bison model, code bison model, or chat bison model. Primarily text bison and chat bison models are available as a part of RLHF. And finally, we're talking about DSS. We will be discussing all these things in details. We're talking about distilling step by step. It's not the pure distillation we're talking about. It's distillation step by step. In that, what we are saying, that your model will be a larger model, your larger LLM will be generating a rationale, and then you will be having a smaller model called as a student model that will be learning from that particular rationale to generate the responses. Definitely each and every approach will be having their own pros and cons. In this particular DSS approach, very interesting approach published by like a cloud AI research team, it's about hundreds and thousands of examples will be needed, but you will be getting a way smaller model, almost like in a range of 500 times smaller model as that of like a larger model. So some of the teachers models available is a text bison model or a text unicorn, and the student model that you can go for is a text gecko. It's almost like an embedding model you can talk about. The biggest question comes in that, okay, hey, what kind of customization, what kind of a tuning that we should be actually using at what point of a time? So definitely the prompt engineering, the prompt definition, the prompt design, you can do it in seconds, in few minutes, in like an hour or so. If you're going for a complex chain of thoughts and so on and so forth, it's an easiest way to generate some initial plan to evaluate that, okay, this technology is working or not, at what level this particular technology is working, and then you can just jump on like hours and days for fine tuning. The biggest advantage for the fine tuning is it's very economical. You do not need to run like a many iterations. You can run few iterations, but you do not need like a millions or billions of data set to tune your model, and you will be able to customize it and personalize it. That's the most important piece in your environment. The biggest advantage right now we are getting for tuning, and the biggest question that I'm getting, hey, if I'm tuning a model on my own data set, will the foundational model learn from that particular data set or no? That's not going to happen. Whenever you're going to tune a model, most of the times in some of the approaches, for sure, we're not talking about distillation, but primarily for adapter tuning, it will create an adapter layer, and that adapter layer will be running in parallel to the foundational model without making any changes to the inherent characteristics of that particular model. And that adapter layer will be stored in your own environment, like for an example in your own Google Cloud environment, and if you're done, you can delete it and nobody knows exactly what happened. That's the kind of advantage that we're talking about. In that case, the knowledge will be retained only in your environment. And finally, we're talking about like training an LLM from scratch. That's like another use case. We started seeing it, some open source models, like even starting with the board based models, and how we can actually get our model parameters learned. Definitely it requires weeks, not even weeks, like sometimes months and quarters, long term commitment, heavy investment, and many other options that you need to consider. Just to give you a very quick understanding that, okay, what kind of a model customization that you can go for. So on the y-axis, they're talking about full model tuning. We're talking about adapter tuning. On the x-axis, we say what kind of a use case you're focusing on. Either you're focusing on domain specific or domain adaptive pre-training. We're talking about PEFT or PET, that is supervised fine tuning or parameterized efficient fine tuning. We're talking about RLHF, that is reinforcement learning human feedback, and then we're talking about final distillation. So based on the green ones that's recommended, it's already available as a part of a Google Cloud, and definitely we can discuss based on your use case what can be used and how it can be customized. That's a quick introduction about how things happen and how you can actually go for the tuning. The question comes in that, okay, how these approaches work, what are the basic differences behind all those kind of an approaches, and let's quickly discuss about some of the common tuning methods. One of a very common question that we get in day out, that okay, hey, whether we should go for full model tuning or whether we should go for adapter tuning. So the key concept behind full model tuning or adapter tuning is summarized in this very interesting paper on LoRa. LoRa is like LORA, low ranking adaptation. In the middle segment that you can see, like on the extreme left, you can say, hey, I'm ingesting an input, I'm getting an output. There are a pre-trained weights. When we say the pre-trained weights, it means it's a frozen model. You're talking about like a Bison model or a Gemini model. It already exists. You can't do anything around it. Definitely about prompt engineering, but that's not the edits we're talking about. The second way we're talking about, it's LoRa, is one of the option, like one of the way to do an adapter tuning. In this case, what we are saying that it will be creating some parallel framework, some parallel initiative to create a dense layer. So in like when we started working with the traditional AI/ML, it's an interesting term. The transfer learning become a very key approach in which what we say that okay, we will be retraining the last layer of the model in such a way that we will be able to ingest my own inputs, and the model will be able to customize and personalize the responses. So the lots of work that has been done on the large language models and as well as model adaptation as well. There are two key things that you can actually do whenever you're working on a language model. The first thing is either you can add an adaptation layer or adapter layer, or the second thing is either you can optimize some sort of layer activations. These are the two key things that you can actually do while tuning or while editing any model in the language sense. Both of these two approaches has their own pros and cons. In this case, we are talking about LoRa, low rank adaptation. Just like the name suggests, low rank and adaptation, it means it's on creating an adapter layer. So it actually allows us to train some of the dense layer in the neural networks, and that's like indirectly by optimizing some sort of a ranking decomposition metrics. I won't go into that much detail, but in a very common sense, we are saying these are the pre-trained weights, these are the frozen model. In parallel, there will be like another adapter layer that will be providing getting some customization based on your labeled example, and the results will be merging together and you will be getting a final response. And when we talk about like a full fine tuning, we're talking about like back propagation, or like what I should say, the learning the loss function itself and then updating the all weights. The full fine tuning requires a lot of data sets to make any tangible impact or tangible changes into the weights through the back propagation, and it requires a lot of like technical skills as well, scalability on the infrastructure, using accelerators, various frameworks, and so on and so forth. So it means the adaptive tuning as such, it's a great approach. We have seen a great success across the industry vertical, be it healthcare, retail, we're talking about travel, we're talking about life sciences, we're talking about pharma, we're talking about it's a different like in each and every industry vertical, we have seen a different kind of implementations. So definitely for the adaptive tuning, it preserves the characteristics of the base model, the base foundational model. It never changes it, but it has some implicit regularization. We do not need a lot of data set, few tens, like hardly like 100 200 of those kind of a label data should be good, where you're providing input and output and the model will be able to tune itself around it. It requires very less hardware, and the best proposition is you do not need to spend any single additional penny to use this kind of a tuned model. The pricing and the costing remains as it is, as that of a base foundational model. But definitely, because it's an adapter tuning, we are creating a parallel structure. If you will be using a lot of data sets, like thousands and millions of data set to create an adapter tuning, it creates a huge risk of overfitting. So in that case, the overall results will actually start going worse instead of improving and providing with the good results out of it. So yes, adaptive tuning, it's a great approach, but we need to be very careful of using that particular implementation. Now, some of the questions that started coming up that, okay, hey, Nitin, what do you mean by supervised fine tuning, RLHF? There is a concept of distillation. Like, how do you define it? So, in that case, when talking about PET, we're talking about PEFT. A lot of those kind of things are coming. Yeah, Satish has a question where exactly the transfer learning fits are different. Transfer learning is it's little different when talking about the transfer learning in like in old auto ML based approaches, where we say that okay, we will be changing the last layer itself of the training network. In this case, we are not making any changes to the frozen model. The frozen model remains as it is. In the transfer learning, you change the whole model itself. Like after changing the last layer, you're changing the core model. In this case, you're not changing the core model. The concept came from that particular approach, but it's not exactly the same thing. You're just creating like another dense layer in parallel to the frozen model that will be sitting on top of the model in some sense. And whenever you're going to make a call, you will be making a call to the adapter model. But your base foundational model remains as it is, but your results will be actually optimized and customized on that particular implementation. That's exactly what you can see on the slide as well. PEFT, PET, SFT, LoRa. These are some of the acronyms that you see across this particular term, but concept remains the same, that there is a one foundation large language model supported by a label data that will create an adapter layer. That adapter layer is like a dense layer for a neural network. And whenever a user actually requests making call adapter layer, it will be making a call to the background LLM, customizing it and providing that particular response as an output. One more approach, and this is like this these days this is getting one of my favorite approach. This is a distillation step by step. Remember, we're talking about DSS. It's not pure distillation. So the concept of DSS works that okay, hey, these LLMs, they are very large. They requires like a really huge um, serving infrastructure. Like in one of the paper published, like very interesting insight provided that serving around like 170 180 billion param model, you need at least 350 to 400 gigs of GPU memory using specialized infrastructure. And interestingly, these days, we're not even talking about 180 or 200 billion param model. We're talking about 500 billion or trillion parameter model. So it means it's a lot. So in that case, this concept of distillation step by step, it becomes really important and really interesting. How it typically works, core concept is you will be having a two model, teacher model and a student model. The teacher model where you will be actually using prompts, and then you will be generating some rationale from that prompts to make it available to student model. Let me take an example in a very similar form. You say that okay, hey, the area of my room is like 10 by 10, like a 10 feet by 10 feet, 10 feet length and 10 feet width. So in that case, the area is 100 square feet. You say I need to carpet it, and I got a carpet of 20 square feet. How much more carpet that I should put? That's a question that I'm putting, and the model is suggesting that okay, your area is 10 by 10, that is 100, 20 is already available, so you should be like you should be needing a 20, like an 80 square feet of a carpet. One of the key inside the rationale from that example is that the area is length multiplied by the width. That's the insight. The core LLM will require a lot of data set to learn this kind of an insight, this kind of a rationale. What if we are going to provide this kind of a rationale to a smaller model, to a student model, and that will be learning it from it? So that's exactly what you can see it on the screen. You're actually providing some label data set. You're creating prompts to create a rationale, and then you're provide like asking it from teacher model. Teacher model is generating that rationale. That rationale is acting as an input of the student model, like another model, and then you will be providing the initial prompts or the initial label data to the student model, and it will be creating a smaller model out of it. What has been commonly interpreted, this kind of a student model is almost 500 times smaller than the teacher model. But definitely, just we say that okay, this is a very task specific model. So in that case, you do not expect that okay, this is going to be a very generic model as that of LLM. Each and every approach has their pros and cons. In this case, this is a very strong methodology, definitely, but this is a very task specific model. Sometimes it has been seen that okay, for a task specific model, it's even outperforming the teacher model, the larger model itself. So very interesting approach, and you can explore it to yourself as well. So one of the common thing is that like for these kind of fine tuning data set, you say the conversation is I ordered a meal at 6:30, and these are things happened, and my meal never arrived. So the summary that okay, meal never arrived. So the inputs versus the targets, that's exactly the kind of a things that we should be focusing on. That this is the input, this is the output. Input output changes based on how you tune a model. Adapter versus distillation versus RLHF. We will be discussing RLHF in a minute, but it's a huge topic. We are trying to distill it again, distillation by step in this session in 30-40 minutes. But definitely we can have a detailed segment for those things. No need to scare away from this kind of an equation. It's a very simple equation. What we are talking about, that okay, hey, how can you generate a response based on the responses that you have already provided or already demonstrated? So if I say that, okay, hey, you always be responding with an acronym of sir or ma'am whenever you're responding. So what I'm telling it to my system, like in form of a tuning, that whenever you do this, you need to apply these kind of a things. One way that you can actually do that, okay, hey, you can just add it through your prompt. One way is to tuning. So definitely both goes at what depth that you want to do. You need to tackle that particular approach. So in that case, you can take all the samples from supervised fine tuning data set, and then you generate a next token. At the end of the day, these models are what will be the next token that you are generating, and if you can impact that particular probability. So what we are saying, for an example, if you are if you're actually prompting we like coding, the target will be the next step, like the next word, and how you can back propagate that particular likelihood that of that particular word. So indirectly you will start impacting that what should be the next word you are generating out of it. So definitely, it's like how you are maximizing that conditional probability. It's a very simple concept. If A happened, what will be the probability of B? Based on those kind of an adapters or those kind of a tunings, you are customizing it and you're providing it like a higher weight to that. So in a very, very simple sense, if you're talking about what kind of a training data required versus a task accuracy, definitely large language model, the large is like the size of the bubble is the size of that particular model. LLMs are pretty large, but you can go for a task specific model that will be smaller. Training data requirement might go up, task accuracy will slightly like remains as it is as that of LLM, but the size will actually go significantly smaller than LLM. So the serving becomes easy, your cost will go down significantly, and multiple other options. I will quickly touch base on RLHF, and then I will pass it to Murari for the next section. They're talking about RLHF. It's like reinforcement learning based human feedback. Very simple approach, very similar approach. What as a human we learn it, as a child we learned it. We say that, okay, hey, I walk, I fell down, I learned that, okay, I just put my step like at a diagonal, not clear. That's a feedback that I'm getting. That feedback we call it as a reward function. The reward function can be coming into various kind of format. Sometimes if a human providing, we're calling it as RLHF. One interesting paper came up. We say that, okay, what if the feedback is provided by AI itself? In that case, it becomes RLAIF, reinforcement learning from AI feedback. So that's exactly thing what the RLHF is. Just to go into the detail, we say that, okay, hey, there is an LLM and there is an unlabeled input data set. You generate output from that unlabeled data set and then send it for the review. The review can be done by human if it's RLHF, or it can be done by RLAIF if it's AI, or it can be like some sort of a programmatic metric. Like one of my favorite is Rouge or a Blue Score, like multiple metric that are coming up these days. So you will be getting like thumbs up, thumbs down. You might be getting like, how can I edit that particular text? And then you get a reward function on top of it. One approach that became quite common last year, it's like a Q star that came up like one of the model as well. It's also focused on a very a similar approach for the reinforcement learning. It actually came from the reinforcement learning itself. So based on that particular reward function, you provide a score, and then it provides a feedback to the model for the fine tuning, and you will be getting a different endpoint or a checkpoint for that particular fine tuned model. So it's an interesting concept. Definitely, we can go into the detail, but just to keep things simple, it requires more data set as that of an adapter tuning. It requires few hundreds, even few thousands, sometimes like 5 to 10 thousands of data sets, unlabeled data set, to create any tangible impact on the model. So just to like give you a very brief sense, for example, if you're asking a question, why don't people put carrots in Caesar salad? Ideally, you should put. I'm a big fan of carrot and Caesar salad, but you should put. But the thing is, it's generating three responses. You are just providing this is good, this is bad, and the model is actually learning from that particular feedback. The second feedback can be, for an example, if you're providing a prompt, you're asking a question, you're getting only one response. Like if you are actually doing some search and conversation on documents. So instead of just providing thumbs up and thumbs down, you're actually rewriting the responses, and it provides a different kind of feedback to the model. So this particular call it as a preference data set or a pairwise comparison. There's multiple options available in form of RLHF or RLAIF, how you want to do it, and so on and so forth. So in a very simple sense, what we're actually saying that, okay, there will be a language model. You call it as a policy. You need to develop a policy for each and every responses or certain set of responses. You like as a human or as a context, you are writing a prompt. It's generating a response. That response you will be mapping it up with your preference data set or from your label data set from your human, and that will be generating a reward. Reward can be positive, it can be negative. Reward can be considered as like a positive, it's a reward, negative is a penalty, but reward is like a common term that we typically use. And then it provide a feedback, and then it will just goes on and on and on till the time you feel like that, okay, the model is good. That time never comes when you feel like the model is good, but that's the whole idea, that you are okay till this point of a time, and you can actually go ahead. One important characteristic for this thing is make sure that the humans that you are actually adding into this loop, they are trustworthy. Definitely. If any spam elements, any adversarial attacks that came out as a part of this RLHF, the whole learning will go away. Your model cannot unlearn. Just like humans, the models cannot unlearn, or it's very hard to unlearn it. So make sure whatever the human, what kind of feedback that you typically add, you need to work on that particular perspective. So, how to minimize it? I won't be going into a lot of those contexts, but learn about this particular term, learning to rank loss. That's a it's a very what I should say closely related to a logistic loss, like a logistic regression. So that's why we say that okay, a lot of these terms are coming from a standard statistics. So it's like a pairwise logistic loss or a logistic loss. That's like an exponential loss. You can see it like a log to the base 2 with exponential with the delta score between winning versus loser based on the penalty. So learn about this concept called as learning to rank loss, that how these kind of a model function works and how you can minimize the reward model loss. So in this case you're talking about, most of the times we say downwards is the most common or most common feedback that we get. So you're minimizing that kind of a loss or maximizing the positive reward values. So in that case, we're talking about, for an example, you're providing a prompt and you're generating two candidates. Like, for an example, I like coding, or we like coding, or we dislike coding. So what will be the next word that I will be predicting after we, whether it's going to be like or a dislike. So based on that delta for that likelihood score for the probability for the next word, it will be providing a feedback yes and no, and you will be able, like the model will be able to learn that whether it should be generating we like coding or we dislike coding based on that feedback. And this is one of the reason the feedback remains becomes very important. And the second one is that okay, how to maximize the PPO or the reinforcement function or objective function. I won't go into that detail. I know I have already crossed my time. I will pass it to Murari. So this is an like interesting concept. I can go on and on for RLHF, very close to my heart. I don't want to get emotional, but yes, this is a very interesting concept to learn about RLHF. And with that thing, Murari, over to you.
Yeah, thanks a lot, Nitin, and really appreciate. I know this is being one of the very interesting topic and one of the common topic, right? As Nitin rightly mentioned, right? The foundational model or the base model may not serve all of your need, right? And that's where the tuning, which is the adapter tuning method, or maybe RLHF, and there are multiple other methods which Nitin talk about, is very important, right? And what I'm going to cover here is basically how does the adapter tuning is going to work as part of Vertex AI, right? And that is what I'm going to focus on. So let me quickly go ahead and talk about that, right? So basically, as Nitin mentioned, there are multiple different ways to do the model tuning, but what we are going to focus here is the adapter tuning concept, right? So you can see onto the left hand side, which is the pre-trained model, which is nothing but the foundational model, which are already available, which is trained onto the very large corpus of the data, right? And again, these are the large extensive model which you have. What you are going to do over here, right, as part of tuning, is that you have very specific data set which you want to go ahead and use, right? And that data set is basically, okay, so this data set is basically, I would say, very small data set, very task specific data set, which you want to feed into the foundational model and then try to basically tune that model, right? So there are multiple different techniques which could be uh, what is a fine tuning PEFT which you can use in order to tune that, but some of the prompt engineering also can also solve, but that may not be the part of tuning the stuff, right? So this is basically one of the thing which you do in order to tune the model and create a adapter layer which is very specific onto the task which you want to solve. And once that model is tuned, and I think Nitin also mentioned a very important point, that you do not have to go ahead and set up extensive compute in order to do that, right? So what you basically do is, you the cost and the performance is still better with respect to with adapter tuning, right? And again, you can solve what will say the generate, classify, and some right type of problem with this adapter model, right? Let me quickly go ahead quickly about the next slide, right? So this is RLHF, which I think Nitin talked about, right? And again, it's just the what will say repetition or the summary of that, right? What you basically do over here is you try to optimize the machine learning model performance with human feedback, right? And what it helps you with to improve the pre-trained LLM without increasing the model size, right? So you go ahead and do the thumbs up, thumbs down, which is nothing but a feedback. Depending on that, it gets what will say reward model trained, and then this reward function basically try to what will say update your model weight and generate output, right? And then you could have a feedback loop based on to the what will say the weight model weight, and then you can try to get the generated output modified for the from the unlabeled data, right? So this is how basically the RLHF works, right? From the model tuning capability point of view. Let me talk about this, and I'm going to demo this also in detail, that how does the adapter tuning works with respect to vertex palm, right? So you will see that in order to do a adapter tuning, and it's very important step to create a data set, right? And data set is nothing but the input output which you are going to refer as part of tuning the job, right? So first and foremost step is to create a data set. Once you have that task specific data set where you have a defined input and output, you go ahead and try to tune the job, and you basically create a tuning job, and I will show you how it can be done onto the Vertex AI on top of your frozen model, right, where the model weights and everything is fixed. When you go ahead and tune the job, a Vertex pipeline is created in the back end, and with the help of that pipeline, what happens, the adapter layer of the model is created, okay? And that model basically that what will say that models gets deployed into your model registry, which is under Vertex AI again. And that you can go ahead and consume that model as an endpoint, right, from which is nothing but a combination of the frozen model and the adapter layer which you have created as part of fine tuning. So both the model will be treated as an endpoint, and that is what you can see it maybe into the last box, where it's not just the frozen model but the adapter layer which has been created on top of the frozen model based onto your data set will come into the picture as a point of endpoint. And then you can go ahead and inference or generate the output or response from that, right? And again, I'm going to show that as a part of demo also, that how does it works end to end into the Vertex AI landscape, right? This is something which is what I'll say is couple of solution accelerator which you can use in order to tune the adapter model, right? So basically, what you go ahead and try to do is you can go ahead and create an adapter layer as simple as, or as I would say as simple as, or maybe as limit as 100 examples, right? It allows you to do the faster tuning, right? So you do not need to basically go ahead with the full fine tuning. Rather, it adapter tuning generally takes approximately 1.5 hours to 2 hours, depending on how much data set you feed. And customer keeps the data set. Again, very important point from the data what is the privacy security point of view, that the data still remains with you, and then the adapter layer which is basically getting created is also stays into your GCP parameter, right? Which is again a very important point of view from the customer ask point of view, right? So if you'll see the pre-trained model, which is nothing but the pre-trained LLM, which is basically on unlabeled data, what you do is basically the fine tuning. So there are three approaches, right, which you can see: pre-trained LLM, fine tuned LLM, and then the pre-trained plus fine-tuned LLM, right? And that's what I was talking about when I was talking about around the previous slide, that you have a pre-trained unlabeled data set which you use in order to create the LLM, which is nothing but a pre-trained LLM. On top of that, you had a very specific data set, and you use that data set in order to basically create a fine-tuned model onto the pre-trained LLM. And finally, for inferences which you are going to generate, what you are going to do is nothing but the adapter tuning, where you are going to use the label data set and then the pre-trained model, and then try to add some parameters, original weight, etc., in order to generate the output or generate the inferences from the adapter layer. Quickly moving forward, this is something which is a recommendation configuration when you try to create a tuning job on top of your foundational model, right? So maybe for classification type of use case or task, you might need 100 plus examples into the data set, and the training steps could be 100 to 500. Similarly, for summarization, if you have what will say use case and you want to fine tune the foundational model for summarization type of use case, sometime maybe the number of examples of the data set could be somewhere 100 to 500, which you might need to tune the foundational model with. And the training steps could be 200 to five 200 to 1000, right? And then finally for extractive Q&A, again you need 100 plus type of examples, and this is again just a recommendation based on to the guidance which we have, right? This is how basically a input data set looks, right? When you are going ahead and trying to create an adapter fine tuned layer on top of your foundational model, you feed a task specific data set, and that's what I was talking about, right? So if you will see, when we are trying to feed the data set, okay, to the foundational model and create an adapter model on top of that, it needs to be formatted into this particular format, which is nothing but a JSON, and it starts with input text, and then you say that as part of input text, this is the question and this is the output text, right? And this is how you basically create a JSON file with 100 plus or 200 or 300 examples, and based on that model go ahead and create a pipeline and then create an adapter layer on top of the foundational layer, right? The second example also, you can see that there's an input text which has been given as part of questions. You also give sometimes the context, and then you give the output text, and basically this is how basically you define the input data to the foundational model, and then tune the foundational model, right? Let me quickly go ahead. So these are what I'll say, very specific, I would say, the general language pattern. So consider if you are expecting a response for a specific word or phrase, how you can go ahead and tune basically a classification model, right? So what you basically do is a prompt. So this is what is basically shown as a part of tuning, whether you want to go ahead and basically try to what I'll say, do something very specific, something niche, and then try to deviate it from the general language pattern, right? So as maybe we know that LLM is capable enough of generating the what I'll say, very specific, or I would say the generic response. But in case if you want to go ahead and try to feed something which is very specific, very niche, that's where you go ahead and try to tune the model. And these are just the few examples which talks about that when the tuning is required and when you want to learn from something specific, right? What you do is, when you are trying to feed the example, right, make sure that you include the instructions in the example, right? So again, this is one of the example which is shown over here, that for tasks such as classification or maybe what I'll say, summarization, etc., right? It's very important that when you are creating the data sets or the example, do not basically contain the instructions, right? You basically need to include the extractions rather than excluding it. And you can see the example also over here, that when you are creating an input data set, which is input text 5 stocks to buy now, and output text is basically this input text quantify, or the context of this input is business, but you need to include the instruction, otherwise the input data set may not be able to useful to fine tune your foundational model, right? And when you are trying to specify, you just please include the context, and then classify and make sure that you include the instructions so that it understands from that particular input text, and then try to learn or create an adapter layer on top of that, right? So the proper example could be that you please classify, and this is again the classification example which I was talking about, that classify the following text into one of the following, and it could be business or entertainment, and then you have given the text that maybe if I have a 5 stock of buy now, whether it is in what I'll say, it falls under the business classification or the entertainment classification, and depending on that, model will learn and try to create an adapter layer. Okay, coming to the last topic, which is nothing but what are the few key consideration, okay, when you go ahead and try to basically create an adoption layer, right? So these are the very important consideration when you go ahead and create the fine-tuned model or adapter model, right? uh, I think there are multiple techniques to do that, right? So it's very important to first of all identify that do you have a valid use case or not. Maybe if your use case can be solved via zero sorts, few sorts, prompt engineering, prompt tuning, you should go ahead with that rather maybe going ahead and fine tuning the model, right? So that is one of the very important thing, that you should understand that whether you have a valid use case or not. The second very important key consideration while doing the fine tuning is that do you have the right team, do you have the right data, because as I said, input data also plays a very important role when it comes to the fine tuning part of it, right? Do you have the enough budget budget for the model tuning. I think there were few questions around the cost side of it, which we definitely take. But again, there would be some additional cost parameter which will come into the picture when you're talking about the fine tuning of the model. What AI stack to use, right? Do you want to go ahead and do the iterations also when you are trying to talk about what will say to manage the model, right? So all these questions or considerations are very important when you go ahead and talk about the fine tuning part of it, right? Let me quickly go to the next slide. When we are talking about the fine tuning, right, one of the very important thing is the orchestration, right? And there are multiple tools technology which are available into the market which can support your end-to-end orchestration. It could be self-managed via, or it could be a fully managed, right? Vertex AI platforms allow you to do end-to-end orchestration, which is nothing but a fully managed service, right? So you can automate everything and then try to use the power of what will say Vertex AI in order to uh, completely govern the orchestration part of the fine tuning stuff, right? We have something called as text to SQL, right? Which is again, I would say, based onto the what will say fine tuned option, right? What we do is we have something called as a uh, what we have done is we have a code bison model, right? So what we do with the help of code bison model is you can give a proper, maybe a not natural language plain text, which can allow you, or which can basically has the power to convert that into a SQL, right? So what you can do is you can use text to SQL add-on, right, which is an online interface which is built on top of code generation, which is code bison. And with the help of normal text prompt, you can the query could be generated, and that query can be used onto the BigQuery engine, right? So this is something which is we are coming up, and again, it's into the private preview, but you could have text to SQL primarily from the BigQuery perspective, where maybe user can go just a simple prompt into the text and the query will be created, which can be which can be executed onto the BigQuery. And again, support beyond BigQuery is also coming into the picture. But you can see the example over here that the user has just given a plain input text in plain English, which is nothing but the natural language. How many cats are brown? And with the help of Vertex AI and Code Bison model, which is in the background, we were able to generate a query which says that select a star from cat where color equal to brown, right? So basically NL to SQL is the capability which I'm talking about over here, right? So with that, I think we have completed the slide. I will quickly move to the demo part, and then we can take the question, right? So let me quickly go ahead and share my screen. uh, cool. Yeah, so I hope my screen is visible, right? So this is the GCP console, which maybe anyone whenever will log in will see it, right? What we are talking about is the Vertex AI platform. So if you come over here and search Vertex AI, you will be able to land it over here, right? And under the language, which is nothing but the different Vertex AI Studio offering, which we have as part of generative AI, you will see multiple different models: Gemini, Vision, Speech, etc. So what I'm going to show you is how to tune the language model, which is nothing but a text bison model, right? So if I'll come over here, this screen shows you that you can go ahead with text prompt, code prompt, etc., etc. What I'm going to do is I'm going to use the tune and distill method, and then try to create a fine-tuned model on top of that, right? So how you can go ahead and create that is you just click on create tuned model. Okay. And I think there are two methods, and the supervised learning and RLHF, which I think based onto the reward model. And I think Nitin has given a very detailed background that how does the RLHF works, right? But consider if you want to go ahead for a supervised tuning of the foundational model, what you do is you maybe give a fine-tuned model name, which could be anything. You select that which, so let me just put right for the namesake, right? And then you select a base model. So these are the base model which you can use in order to create a adapter or a fine-tuned model, right? So these are the different model which you can use. So maybe for time's sake, or maybe for just example sake, let's consider text Python. You select the reason, and this is where you want to persist the adapter layer of the model, right? So as I was saying that the model basically gets stored into your GCP parameter. So whatever path you are going to give, basically the model is going to reside over there, right? So basically you create an output directory, and then the model going to resides over there, right? Once you do that, you feed the input data set, and then with respect to that input data set, basically, let me just put that path also quickly. Okay, so if I'll go ahead and continue, what I need to do is I can upload the tuning data set, and that's where I was talking about, that the data set, which is nothing but the consist of the different scenarios example. Okay, and you just basically upload it from the cloud storage, or even you can go ahead and upload it from your local system. Once you upload that what will say a JSON file, which is nothing but the input data set, and then you select that, okay, where you want to basically, so maybe you can go ahead and upload it, or either you can go ahead and give the GCS path. Once this is done, you just go ahead and tune that model, right? So maybe if I'll just show you, right, I can again go ahead and put this path, right? And once this is done, right, I can go ahead and select this particular data set. This is not getting selected because it is already being used right now, but I can go ahead and select this and try to use it for the model, right? And then once it is done, I can directly go ahead and I can go ahead and directly use it basically for the tuning of the model, right? So this is how you upload the data set also, which is primarily very specific for tuning your job, right? Once you have done everything and you created an adapter layer, right, it takes some time to create that adapter layer, but once your model is ready, you will see it over here, right? And that's what I was talking about, that the model lies within your parameter. So all the artifacts which is related to that particular adapter layer model will be stored into your GCS bucket, right? So you can see all this stuff, right, which is over here is related to the adapter layer of fine-tuned model which has been created, right? Once this model is created, you can go ahead and see that model also as a part of Vertex AI model registry, right? So all these models will get stored over here as part of model registry, which is fine-tuned model, and then you can consume it from here directly as an endpoint. So you can see the status of this model is deployed, and it's nothing but a large language model, and it is trained onto the base model, which is nothing but a text bison 2. Now let's see few of the examples that how these models behave, right, when it is fine tuned, right? So I am going to use the fine tuned model, which is nothing but the name which I have given is LLM opposite, because the data set which I have used is just for the opposite keyword, right? So if I just give a prompt into the fine-tuned model which I have created, which is nothing but the mobile phone, and submit. Okay, so it goes and generate a response which called, maybe let's see the response. What is the opposite of mobile phone? So the opposite of mobile phone is nothing but the landline, and the data set which I have used is consist of few opposite words, right? Let me just show you the response. So this is a fine-tuned model which I am using, and if you'll see, I have not given any specific prompt. I have just given a word which is nothing but the mobile phone, and the model understood the context and just created, or maybe just given a response as a opposite word. If I will do the same thing, right, with a normal text bison model which is there, right, which is a generic model, it will it will not understand the context, right? And what it will try to do is it will give all the details about mobile phone. So what I did over here is just I have given a prompt which is nothing but the mobile phone, and what it did is it gives me all the detail about the mobile phone, that okay, when what is the mobile phone, when it has been, what will say, invented, etc, etc, right? So hence the output, if you'll see, is differ between the fine-tuned model and then the foundational model, right? Foundational model may not have the context and may not have been, what will say, optimized for that particular opposite functionality, right? However, when I fine-tune the model, I have specifically fine-tuned that model for that opposite word, and hence I did not have to go ahead and give more context and details when I'm writing a prompt. Let me show you second example. Again, I'm using a fine-tuned model which I have created, which is nothing but the LLM opposite, and I'm saying that please tell me opposite of country. Okay, and here I'm giving a complete prompt, just for the demonstration purpose. It gives me the response as city. And if I will go ahead and use the same text bison model and give the same prompt, which says that please tell me the opposite of country, into the what I'll say into the prompt, using this particular model, then what it says, it may not have understood the context, right? And it gives me multiple different possible response which could be possible, right? So that is how basically it is not contextualized. The response is not contextualized based onto the what will say the response which you are looking for, and hence the fine-tuned model is more contextualized and it directly gives you the required output, which is nothing but the city. But since this is a little bit of generic model which does not have the context of it, hence it gives all the different possibility which is possible with respect to this particular keywords, which is you are asking about, right? So with that, I'm just concluding my demo. If you have any questions, feel free to ask and we'll be happy to take those questions. uh, we can go ahead with the questions.
Yeah, thanks, Murari. Just one thing that I want to add when talking about these kind of a fine tuning, the concept of fine tuning and the concept of RAG, that is a retrieval augmented generation, or having an embedding, it's different. When you're creating an embedding, you're not actually creating, or you're not actually fine tuning a model. You're going for a grounding, and that the whole concept is different. We will be having a dedicated session on that embedding. If you're interested to understand, I think I saw a question of TID, if you're interested on that kind of a concept, I strongly recommend you to go and join that particular session to get a lot of clarity on those concepts. In this case, and I think Anil is asking some questions around about exporting that model. Just like we discussed when talking about the adapters, you're getting an adapter layer, but still it's dependent on the core LLM function that's running. You are independent to use these kind of a models anywhere, just like Murari showed it to you. You just need to make an API endpoint call to that particular tune model, and then you can integrate it with your on-prem, with your any other third-party cloud provider, so wherever you want to. So that endpoint will be there running on GCP, and then you can integrate it as a part of your end-to-end pipeline product extension, whatever you want. Cool. Let's jump on some questions. Yeah. So these are some of the resources that you can surely go for. Yeah, for an example, like a cloud community or event feedback, we would love to get your feedback to target what kind of next sessions that we should be building, feedback on this session, at what depth that we should go, what kind of a questions or anything. Please feel free to like share. And these are some of the upcoming events. Code with Duet AI. I saw one question that how Cody is different than Gemini. I strongly recommend you to join that particular session, Code with Duet AI. That's how you can customize your code versus you can use some out of the box assistant or a Cody that based off a concept. I'm a big fan of like this embeddings with custom application. Very very powerful session. I will strongly recommend to join. One common question that we typically get is how to make AI secure, prompt security, prompt safety, that kind of a question. So on February 15th, you should join that session. And RAG, that's a sweetheart for almost everybody these days, to ground your solutions, to ground your responses on these things. So it's a very good session on RAG, how you can navigate like regulations, authorities, regulatory approvals, and a few other compliance related things. It's a very very interesting concept. Cool. So let's go for few Q&A. Yes, Murari, do you want to go for it?
Sure, yeah.
Sure, please go.
So should we? So the question again. Thanks a lot for asking this question. Right. So should retuning be done on the previously tuned model, or should it be done onto the foundational model? Again, very good question. Right. So it depends. Right. Uh, Maybe depends on your use case. Right. So if you feel that the fine-tuned model which you already have, right, just need extension, right, based on to few new data set, what I would recommend is you can go ahead and use maybe the same method and then maybe try to tune the existing model. If the use case completely is different, right, it's a new use case, definitely you can go ahead and basically use the foundational model for tuning it, right? So both the approaches are fine, but it completely depends on scenario to scenario, I would say, right? Maybe if Nitin, you want to add anything over here?
Just like a one thing, I typically won't prefer to just do a retuning on the previously tuned model. Just like in the past, it will just cascade your losses and the dependencies will go very deep, and there's a very high chances for the overfitting. You can go for like an incremental tuning. So instead of going for tuning after tuning, you can just say that, okay, just keep adding the data. But again, adapter is not a panacea. So don't consider it that, okay, I will just keep adding my data and input and I will keep getting my responses. So don't go for it. Keep it limited and very, very task specific.
Yeah, and I can see that there's a question also, can you edit the response to further tune your auto model? So I think this will also be covered as part of this question, right? So the answer will remain same as Nitin said, right? That if you want to go ahead for retuning, again, there's a overfitting thing which will come into the picture. But the suggestion or the recommendation is that maybe you should go ahead for incremental tuning or maybe a new phrase fine tuning. We can go ahead with the next question. Nitin, you want to take this?
Yeah, sure. Will I need to refine tune after That's an interesting question. It depends. Model evaluation, it's a very interesting concept that we are currently working on. So definitely the concept of model drift that has changed a lot. You do not need to fine tune for every model release. A lot of the times you feel like that, okay, if your model, the tune model is actually working on your concepts, on your business, it's okay. But if you feel like that, okay, no, I need to fine tune it on the latest version, something like that, it's your call. So there is no right and wrong answer. It only depends at what level your business is moving. If your business is very stable, you're happy with the current solution, why do you need to like tune it? It's already working and so on and so forth. Until unless you're getting some trade-offs like cost, latency, and few other things, then you can actually then you can actually go for it. And when would I fine tune versus just tweak my prompts? Uh, so whenever if you want to make your changes in your model itself so that you do not need to provide those prompts again and again, your chain of thoughts again and again, and you say that, okay, those kind of a standard things. For an example, one demo that Murari showed it to you, you need to create an API where you just provide a word and you're getting an opposite. So instead of like fast tracking it or adding this prompt so that nobody can actually add anything else, you can go for a fine tuning. So if you want to add some inherent thoughts, you can go for a fine tuning. Or if you say that, okay, I want to make that adapter layer available across my organization for a particular problem solving. So there are multiple options that you can decide fine tuning versus just prompts, and as well as performance improvements that you can get. Cool. Yeah, Murari.
Yeah. So, are there any specific tuning best practice to consider when it comes to frequency? How often to retune periodic batch versus online volume versus diversity? So I think this is the question which we have covered by and large into the first question. So basically, retuning or periodic batch or online, it completely depends on to the use case to use case, right? But the recommendation, the guidance would be either do the incremental tuning of the what will say foundational model based on to the new data which you are getting it, and maybe if the diversity of the data is coming up, because if you are trying to go ahead and retune the same existing model, the overfitting or maybe the what else cascading effect is something which can come up, right? So that's where maybe it is recommended that if you have new data, go ahead with the incremental what will say tuning of the model, or maybe if the data volume is huge, right, which is the incremental data, you can even go for a phrase fine tuning also, depending on if it is a quite huge variation from the previously existed data. Cool. Nitin, you quickly want to take this?
So how effective is the parameter efficient fine tuning for adding new knowledge to the LLM, or it's only good for teaching the LLM how to answer? So thing is, this PEF tuning, it's primarily being created to make your responses customized. Definitely, to a certain extent, you can add a knowledge, but remember, this particular knowledge is not going back into the LLMs. The idea behind PEFT is to customize that your responses for a specific type so that your model will be behaving in that particular personalized fashion. So I will not blanketly say that, okay, no, you cannot add new knowledge. You can add, but to a very limited extent. Don't expect that, okay, hey, the model will be able to start building up that connections with your base model, because the knowledge, the data that you're providing, it's not going back as a part of the base model. Rather, it's only creating a part of the adapter layer. So to a very limited extent, you can add some knowledge, but not. It's primarily focused on adding like a specificity or personalization or customization on the responses and tuning it around it.
Sure. Yeah, Nitin, I think we can take few questions which are there in the chat, live questions, right? So I can try to bring it if you want.
Sounds good. One question, it's like, is there any approach for tabular data? It's very close to my heart. Like me and my team is actually working on on this particular problem for a long time. Murari is my partner in crime on that case. We are so I will not say that okay that problem is solved. One of our colleagues, Sarkan and his team, published a paper called as Ingest Tables. Just Google it, Ingest INGES Tables LLM. You will find that particular paper. They used a very interesting methodology using LLMs to create a model for processing some tabular data. It's outperforming the XGBoost model. Is that scalable? Is that generic? We still need to run those experimentation, but there are multiple approaches. That okay, yes, tabnet sometimes it works, sometimes it doesn't work. If you say that okay, anything like tabnet versus my tuned XGBoost, will it outperform? It's not easy. The processing tabular data is not that easy. There are multiple options that you can go for it, but be very cautious while working on tab data. Cool. Interesting. Hey, Tushar. ML ops, is it possible to migrate fine-tuned model from one? And interesting questions. Tushar, the thing is, how, after these LLMs, the concept of all those standard software development lifecycle as DLC is being changing, like test versus UAT versus prod. There's no concept of model, what I should say, migration
My
or model maturity. That okay, yes, I'm actually maturing my model from one environment to another environment after going for model validation. So those concepts are changing. The concept for data drift versus model drift are being changing. So definitely it requires a detailed session. I think we have a session on ML ops. We are almost on the top of the hour. We will be taking that thing, but at the moment you cannot migrate a model, but it's easy. You can create like another adapter layer in your environment after validating in the dev, and it should be working in exactly the same way. Cool. I think with that, we are almost on the top of the hour. Thank you so much, everyone, for your time and for all the enthusiastic questions. We are glad that okay, you're asking those questions because these are the questions that need to be asked while using LLMs. And feel free to like share more questions and feedback, how to use those prompting, how to use those kind of fine tuning. Keep using Vertex AI, and we'll have to like come up with more sessions. And thank you so much for your time. It's great talking to you all, and have a great
Yeah,
rest of the
thank
day.
you, thank you, thank you, everyone. Thanks for your time. Looking forward. Yeah, thank you.